Hello everyone, I'm going to showcase my circuit designs that I have been working for about 2 days or 3 days, I'm not actually sure. So, in my first design, this is a disc, as you can see. And it basically works kind of like a disc, kind of not. It's basically inserters on a chest. Yeah, that's simple. I know, fairly simple. So, to write the data, I just need to set the memory address of the written block. For example, if I want to write to the 13th block, I just need to set this to 13. And then I need to set the in data to whatever you want. For here, I set to 147 because why not? And then I'm just going to push start for a few seconds and wait for it. It's going to do something. I think, maybe. So where's the 13th block again? Oh, it's here. Yeah, as you can see, there's things over here. Exciting. Woo. Really exciting, I know. And if I want to read the data to 13, it'll read it to here, 147, as you can see. Like, if I want to store the data, what about 137? That's a nice number, I believe. And I turn on for a few while. Is that even thing? And I stop it. It will be a different kind of data into here. And then if I read it, it will show. Wait. Oh wait, yeah. I forgot that I need to reset the thing, and then I need to start the thing. I am so good at this. And then the data should be 137, as I said over here. The reason I wanted to make this is because on the last video I made, I probably didn't upload to YouTube, I uploaded to Reddit. I was making a thing that shows letters. Yeah, basically a LED panel that shows letters. And it was lagging a lot because there were too much circuit going on, and there's too much memory modules that carries too much data. So basically my UPS was 10 at that point. So that was not fun. But I figured out that this design is too not compact. Is too, how do you say that? Not compact, whatever. You get the point. It's not compact. And it's really slow to write, but read is almost instant. Which is pretty nice, but because it's a disk, so writing must be slow. But sooner I've developed another thing called user memory. I mean, just ignore the user part, this is for some other thing. And this is actually better, I believe. So here's the address and here's the data. If I want to store the signal 35 at position 60, for example, or, okay, let's just say position 30. And then I turn it on and off. Then at position 30, somewhere over here, I just passed it. Yeah, and here there will be the signal 35 will be stored. And then if I want to read it, I just need to say position 30, and yeah, wait. And then this will show the signal 35. That's pretty cool, and that's basically how I did through the 2 days work. But every single thing, these things are modulable, so basically I can just copy this thing, and then I could just plot down as many as I want. Another reason I don't want to do the disk is because I need to do every time. I'm using creative mode, so these will get autofilled. Just took all the state. And yeah, that's pretty nice, but this is really frustrating, me at least. But in this design, you could just plot down as many as you want. Another thing for this design is that this is actually compatible for an actual computer if you want to do one in Factorial, and that is what I'm trying to do, and I will show you the concept for it later. Because I need to time the ticks perfectly in Factorial to get the memory because of stupid reasons I didn't design this too well, I could actually put down this thing that outputs one signal to here, so that even if I plot down like 20 things, it will still show how much ticks I need to wait before it reaches the last block, so that it will always reach the block before it gets the data. This thing is what I'm actually working on right now. I just quit because it's too complicated for me right now. Just gonna work on it tomorrow morning, I guess. This is the actual concept of this is my idea to make a thing that's basically like an operating system in Factorial. To make a program, you need it's basically like assembly. You need you need one control byte for each statement, and you need some extra information at the end. For example, I have these. I have the control byte. I have separated into two parts. The first part, if it's 1, it will be a memory operation. And if the last 4 bit is 1, then it's allocate. If it's 2, then it's delete. By the way, I used the C programming language, so it might be more relevant if you do that too. And it will have a number after it to define like the address of it, or it will just say allocate 5 bytes or free this address. And then a 2 will represent arithmetic/logic operations. This is where the magic happens, I guess. Like, you could do 1 to 9 operations. It's basically how much operations this thing has. Oh wait, I forgot to do remainder instead. But you could put these, and then you could say add memory address 1 to memory address 2 and get memory address 3. And you could do it for all of these things. Then the third one is statements. It's really important too. It's only possible for me, at least, to implement 3 statements, which I think is all you need to make a program, I believe. The first one is an if statement. Tracking for else statement is too hard, so just an if statement is enough. You could just be like, if this equals true, and after that you could just say if this equals false. And then there is a goto. Goto is basically like the while and for loop, but for assembly. It's in Fortran 2, I believe, but no one uses goto in C, even though it is in there. And if you're using goto, I haven't figured out how to do, like, mark this line to A, and then you could go to line A, but you could just go to line 4, and it will go to the line that's relative to the start of the program, which is line 4. And then there is a break, because if you want to do a while loop, then there is no while loop in here, so you could just say if this thing is test for statement, if it's true, then it will break, which is nice. Other things that I need to do before doing all of this is make the memory work in bytes instead of signed 32-bit integers. Basically, in these things, it could only go up, I won't say only, but it could go up to 4 bytes, the value of 4 bytes, and it's signed, so it's technically 2 to the 31st power. Yeah. So that's weird, and I cannot change it, but I can, like, put 4 bytes into one of these combinators. It'll be really difficult, but I think I could pull it off. And then the other thing would be make the memory allocator. Oh, make the memory allocator. Yeah, this thing. This is... I might need to explain it. Basically, this memory allocator is going to be like, if I want to allocate 5 bytes of memory, then it will allocate it 2 to the size that is to the power of 2. So if I want to allocate 5 bytes, I'll need to allocate 8 bytes for it. And then I will store the position here. And this is basically a linked list. There's 16 things in here. So, for example, this will store all the ones that is 1 byte. This is all the 2 bytes. This is all the 4 bytes. This is all the 8 bytes. This could only store 1 position. But if I free 1 space over there, then I can mark the position over here, for example, and basically like mark the next position that is freed. So I could. This is basically a linked list, and if you want to regain memory that you have already abandoned, then you could just go to here and go to the first position here, and then put the next position into this position, and then this space is going to be yours. It's pretty complicated, but I have actually like implemented almost 20 times in my code. I think I'm exaggerating, but it's really fundamental for the memory management. So yeah, that's basically it. I would try to make this into a computer, I guess. But school is starting, that is why I'm doing this video. I mean, another reason I'm doing this video is because, like, I was working on a program, and, oh wait. You can't see my password because if I do make, yeah, that's a lot of errors. And I'm frustrated right now, if you can't tell. I'm very frustrated. By the way, I don't know how much lines this is. That's like 10,000 lines that I have written in 3 months. That's a lot, I guess. Okay, so that's it for the first video that I'm gonna upload on this channel. And I'm probably gonna send to Reddit too. So yay! Bye. Oh wait. Never mind. I'm supposed to Control Alt.